Hi, this is Larry. Today's topic is normalization. We want to talk about normalization because what we're trying to do is to analyze an entity at the attribute level. There are three forms that we're going to talk about. There are actually more, but we're going to talk about the three forms of normalization. And we're going to look at it from a bottom-up approach because that's the way that most normalization is utilized, from a bottom-up. Are you ready to go? Certainly. So why do we do data normalization? Well, basically we want to make sure that the data model is correct and complete. It doesn't have redundancy. What we're going to do is look at reducing the data redundancy within the models. Can we completely eliminate it? No. In a relational database, we're going to have keys and associated keys, so there will be some redundancy, but it'll be very minor. And actually, by normalization, we help to tremendously reduce the amount of redundancy. The other thing is we're going to eliminate any update anomalies. What this means is that any kind of problems you may have when you go to insert data, when you go to update data, or you go to delete data. Understanding that when you do things within a relational database, you can affect more than one entity. Meaning that if some customer has some information here, that might affect all their different orders. So the thing is, you have to understand that normalization will help to eliminate update anomalies. The other thing too is it ensures consistency in models, meaning that you have very good consistency between all the rest of your database, which means you also have structural correctness. If you go through and do normalization to all the entities within your database, you help to make sure that the database is correct and being able to make it more efficient. So there are some concerns. Yikes! Yes, there are concerns using normalization that you need to keep in mind. The first is that normalization does not reflect the business requirements. So it cannot validate the accuracy of a model in reflecting business requirements. So basically means that the normalization process does not capture the business rules and data requirements. So therefore it does not define what a good model is. Basically, normalization does not consider the entire database also. Only the entities that are being investigated. When you start with attributes to entities, you're only looking at very small areas of the database itself. And the database may have a lot of different tables inside of it. So basically what we're looking at here is that you need to understand that you're going to do normalization, but you also then need to also incorporate it with the next level higher from it, which is the logical model of the entity relationship diagram, because that has a more accurate representation of what the business requirements are. So those two work in hand. Don't just think that you have a normalized database, that it's actually all entirely correct. So when do you do it? Well, most normalization happens in a bottom-up fashion, meaning that you're going to have some kind of existing database or some report, or some people are using Excel spreadsheets, or some even an Access database you have around, okay? And then you need to put it into a more functional database. So people have already identified and come to you, here's the data that I want, or here's what we think, and then you have to kind of assemble it and then create from that all the attributes, create tables or create entities, what am I saying, and then eventually create tables, but create the entities from all that. And you work from a bottom up. Because when you get done with that, then you go to do the entity relationship diagram. And you kind of bounce back and forth. Now you can also do it in a top-down method, but the first thing you start with would be the entity relationship diagram. And that's then what you use is that normalization is used there is to show the correct assignment of attributes and that you have the correct number of entities. Understand that ERD is not performed and does not identify the correct entities, where normalization will. Now there are three forms that we're going to talk about. There are more, but most organizations will at least go to the third normal form. A form is a stage in the process, meaning that the reason why they're called forms is that each stage is called a form because of what the format of the data is defined in. Meaning that for each form, data is defined a little differently. Okay? Can go beyond the three, but I wouldn't worry about doing that. Okay? Make sure you at least know how to do the three. You can stop at any stage or form, basically. If you have something what is called first normal form, that is at the minimum, every entity that you have in the database must meet that one. Can it run well and be effective and efficient at the one first normal form? Yes. If you don't have it at first normal form, you're going to have problems. Okay. So what are the three forms? Where there's the first normal form, there's the second normal form, and the third normal form. I like to tell people, if you can remember the Three Stooges, certainly, that there's Larry, Moe, and Curly. If you can always remember that when you're going to be doing normalization, you can either work with just Larry, or you can work with just Moe, or you can work with Curly, okay? So you can go to all three different normal forms and you can work with them, okay? So what is first normal form? I'm going to go over each one, just a brief definition of each one. An entity type is in first normal form when it is a unique identifier exists. What is a unique identifier? Basically a primary key. And there are no repeating groups. What's a repeating group? Meaning that you do not have things to be able to repeat themselves in the same table in the database. At first normal form, you're eliminating that data redundancy or reducing it greatly. So that making sure that you have the data, the attributes not being duplicated over and over again, even inside the own entity within itself. If you do not assign unique identifiers, you're going to end up with a lot of repeating groups with a lot of bad data out there. And all attributes then therefore must be dependent upon the primary key. Meaning that what you're trying to do in the first normal form overall is identify what the primary key is. Now keep this in mind. Keep this in mind. A primary key does not mean it's one attribute. A primary key can be one or more or multiple different attributes within an entity. Keep that in mind. That's normally and not unusual to see that. When you try to just go assign a primary key creating one, just one, like a unique identifier, like give it a number, okay, a lot of times you're going to end up having a lot of problems with the rest of the entity, and that's why it's not normalized correctly. Second normal form means that the entity is second normal form when it's already in first normal form, meaning that to get to Moe, you already have to be in Larry. You have to be a Larry to become a Moe, okay? And no partial dependencies. So what does that mean? Well, if you have only one primary key or one attribute being part of the primary key, there's a high chance that you're already in second normal form. What you're trying to do here is that you're trying to eliminate any partial dependencies, meaning that there are no attributes dependent upon only a portion of the primary key. So if you have, let's say, two different attributes that make up the primary key, it could be that, and probably highly likely, that there are elements of the inside of the key, the entity itself, those attributes, that reside more specifically to one of those one of the two different primary keys. Therefore, you're going to end up having to separate that out and create a new entity for that. But you have to keep the first one at first normal form the same if you've got more together. You'll see that in another video. Okay. Third normal form, guess what? Means you have to be a Larry to get to be a Moe, then you have to be a Moe to get to be a Curly. Does that make any sense? Well, basically it is. Means that 3NF means that it already has to be in 2NF. And then there's no transitive dependencies, meaning that there's no partial dependencies. You're going to see examples in another video, basically where it identifies what a transitive dependency is. It means that you want to be able to make sure that you have no transitive dependencies, meaning that it's another element in there for which a lot of the items, and it wasn't part of the primary key. A transitive dependency means that if you do have something inside an attribute, inside your table, that you, I shouldn't say table here, but an entity, if an attribute inside an entity, which other attributes are more likely dependent upon than either one of the other primary keys or a primary key in there, that then you need to be able to move those out to another entity into itself and reference that back. That's third normal form.